Hi everybody, in this video I'm going to talk about how to transform basic graphs of linear functions. In order to understand how to do this, it's important to know that to transform a graph means, in its most basic sense, to move a graph either up, down, left, or right from its original location. And that the original location of a graph is given by what's called the parent function. And to illustrate that, I have these two examples here. So on the left side we have the graph of f of x is equal to x, and you see I have a basic input-output table with 3 inputs, whereas on the right side we have g of x is equal to x plus 5 with the same 3 input values. Now the first thing that might have struck you by this time is that the input values are the same for both functions. And that's because I want to keep a fair comparison between the two of their outputs. But the other thing might be that f of x is equal to x and only x and nothing else, whereas g of x is equal to also x but plus 5. And you can see when you look at the outputs right over here between the outputs of f of x is equal to x and the outputs of g of x is equal to x plus 5, you can see that the values are indeed different. And to explain how this happens, all you have to understand is that we're taking the same output value, or rather the same input values from f of x, which are the negative 1, 0, and 1, and we're simply adding 5 to that. And so negative 1, if I were to create the transition here, it would be that negative 1 plus 5 makes the 4 that you see on the right side. 0 plus the 5 makes the 5 that you see on the right side. And 1 plus the 5 makes the 6 that you see on the right side. So with this in mind, we are able to look at the graphs and see how they actually vary from each other. So let's go ahead and take a look at that. I'm going to take the input-output values and create 2 lines from them. So the first will be negative 1 and negative 1. So negative 1 would be right about here. Then we have 0, 0, which is here, and then 1, 1, which is right here. Okay? So the line for this graph would look something like this. I'm just doing a very rough sketch here, as you can see, just a very rough sketch. And this over here would be my f of x is equal to x. Now, the other one, the g of x, is equal to x plus 5. Well, if I were to graph that, I'd have to use negative 1, 4. So that would be over here, negative 1, and then up 4, 1, 2, 3, 4. 0, 5, which would be 1, 2, 3, 4, 5. And then 1, comma 6, which would be 1 over and 1 up from there. So my line would look like this. Okay, and again, this is just a rough sketch. This would be my this would be my g of x is equal to x plus 5. So one thing that you should note here is that when comparing these two graphs, the green and the yellow graph, they are parallel to each other. That has to do with a phenomenon known as slope, and I'm not going to discuss that in this video as it does not apply at this time. But it is important to note that they are parallel. Also, they are simply apart from each other by 5 jumps, and I can prove this to you. If I were to grab this point over here, let's say I grab this point over here, 0, 0 at the origin, and I were to hop up 5 units, 1, 2, 3, 4, 5, I land on its corresponding point on the other line, which is the sort of like the kid function, if you want to say. If this over here represents the parent function, then so parent function, then this over here would be like the quote-unquote kid function. and this is by no means an official academic label for this g of x function, but I like to call it kid function because it shows that there's some kind of connection to the parent function, and this is where it came from. We just add 5 to the parent function, and there you go. You get the green one. Okay, so and you can do this with every point. If you grab any yellow point and you count the units up by 5 units, you'll land on its corresponding point on the green line. Okay, so this is how that works. All right, let's take a look at another example here. In this example, what we're going to do is we're going to take the function you see right over here. We're going to take that function, and what we're going to do is we're going to translate this according to the directions. We're going to translate it 3 units down. So this works by grabbing any 2 points on this line and simply moving them down 3 units and relocating them to those places and anchoring them there. So I'm going to start with my origin, and I'm going to count 1, 2, 3. Okay, so this is where it's going to end up. And I'll use, you know what, I'll use another color just so that it's not confusing. There's my new point. And to be really accurate, I'll call this A, and I'll call this A prime as my new point. And then I'll grab another point. So another good point would be this one over here, and I'll call that B, and I'll move it down by 3 units. So 1, 2, 3, and I'm going to anchor it right here, and this will be my B prime. So I can see that my 2 points will create a line, and hopefully I can do a good job of drawing this here, but they create a line which is parallel to the original line made by y equals negative 4x. And because I have translated the whole original line down 3 units, what this means is that this y equals negative 4x is not going to be y equals negative 4x anymore. It's going to be, pardon me, it's going to be y is equal to negative 4x, but then with a minus 3. And that minus 3, this represents, this over here, this represents that I have moved down. Change my thickness here. That I've moved down. So, moved down 3 units. And that's why it's minus 3. And that's why it goes there. So, as you can see, for the first part over here, this part represents the parent function, the original one, for this transformation. And then this minus 3 shows what I've done to modify that original function into its new form, which is the red line you see. Okay, last one over here. So for this one, I'm going to translate this 2 units up. Now, I see that I already have something over here, so I need to keep that in mind. That negative 2 simply has to do with where the line intercepts the y-axis, which is right there at negative 2. So if I need to translate this 2 units up, again, I have to grab any 2 points. So I'm going to grab, let's see, I'll take this one, and I'll move it 2 units up. 1, 2. And I'm going to anchor it right here. So there's my anchor. And again, this is A prime, and this is the original, which is just A. And then I'll do the same thing with another point. I'll take this one. I'll call this one B. And I'll move it up 2 units this time. 1, 2, and I'll anchor it right there and call this one B prime. Okay, and then I have to go ahead and make my line for this, so I'll do the best that I can to make this line accurate. So it'll be something like this, something like that. So once again, this line is parallel to its original form. And now to write the new function form, I have to keep in mind that this whole thing over here represents the original line that I see there in black. But I'm shifting it up 2 times. So I have to account for this by adding 2 at the very end. So if I take this into account, my new function, so the new function would be y equals, and I'll do this from the beginning, so y equals -3 minus 2, but then plus 2. So that means that y is now equal to -3x plus 0, because these two values here, they simply nullify each other, and I get a function that's called y equals -3x, and that is the graph of my red line. Okay? And that represents having moved the original 2 units up. So I hope this video helped. Please stop by, leave a comment, and as always, thank you for watching. Bye-bye.